So welcome back to everyone. Now we are here with the next session of our StrimziCon. We are here with Steffen, Karlsson, Sai, Charan, Madhvaraj, and Ravikanth Mallappa from Maersk. And they are going to talk about transition to Apache Kafka on Kubernetes with Strimzi. So hand over to you guys.
Thank you, Paulo, and thank you for having us here. What we want to tell today is a classic migration case study. So we will discover how our past solution were, how it's now, and a bit dig into the future, how we want to be in the future. At Maersk, we have had a transition from Confluent platform and Confluent Cloud to self-managed Apache Kafka with Strimzi on Kubernetes, and that's what we want to dig into. So yeah, as you said, I'm Steffen Karlsson. I'm a lead engineer in the streaming services department in Maersk, where we both have MQs and Kafka, and hopefully some more in the future. We'll dig into that later. I'm joined by my colleague Sai, who is the lead engineer in our Kafka team, and Ravikanth, who is our lead platform architect within the streaming services department. So what are we going to talk about today? First of all, if you don't know what Maersk is, I will quickly tell a little bit about the company. Then Ravi will dig into the past and a bit into the present, where Sai will discover the architecture and the features of our Strimzi platform. Then we'll go through tooling and a lot of extra things we have added on top of Strimzi. And then last but not least, we'll talk about the future, which plans we have for our Strimzi setup. So what is Maersk? Some of you might have seen the blue star before. We are a global integrator logistics company. In the past, primarily focused on ocean, but now we are transitioning into our 2030 integrator strategy. So we want to deliver end to end. And when we look into that future, it's clear that we must take the next steps to deliver truly integrated logistics. These next steps could be connected physical assets like warehouses. Maersk is building warehouses these years, but also new digital and distributed platforms. This is where the event streaming comes into place. Yeah, so Maersk want to upgrade that data and technology capabilities to provide an even better end-to-end logistics for the companies that are using us to move their cargo around globally. And over to you, Ravi, for our previous setup.
Thanks, Stefan. So, with that background in mind, let's reflect on the past, going back around 5 years, and our need for event streaming capabilities. So, why we wanted to have this event streaming capability in Maersk, right? So, as Maersk started its journey to modernize its applications for speed and reliability, we had to transform from a batch to event driven architecture, that is to process data in real time. So Confluent Cloud, which is a SaaS offering from Confluent and Confluent platform, enabled us quickly to set up our environment or event streaming platform without a need to manage a complex infrastructure. So this allowed us, the business platforms in Maersk, to focus on development, to use event streaming capabilities while we make the platform available to them. Right. And using this kind of reliable and consistent data streaming solutions helped us gain the trust of our business stakeholders by ensuring high availability and real-time insights into the events or the data. Also, last but not least, the pay-as-you-go model of Confluent allowed us to scale based on demand to some extent, optimizing the costs. Uh, can you move to the next slide, Stefan? So, based on these needs, what you are seeing on the slide now is the past architecture that depicts how we were able to set up our event streaming platform initially using the Confluent offerings. So we have applications hosted in our data centers, which is our on-premise environment, which needs to exchange these events with the consumers on cloud uh, and vice versa. So to achieve this, we have set up Confluent platform in our on-premises data centers using Docker containers running on VMware virtualization environment. And using the Confluent replicators, we are able to sync the data between these on-prem data centers into the cloud. So, along with the native Kafka producers and consumers, which are producing and consuming to this Kafka system, we also have considerable amount of applications. Those interact with our MQ infrastructure in streaming services. So to connect this estate or to integrate this MQ estate with the applications hosted on cloud, we have implemented also Confluent connectors. So along with these, we have also used Datadog for real-time monitoring, and we adopted to GitOps like approach using GitHub and Azure DevOps pipelines to set this environment up and then provision the resources to the business platform teams as and when needed. So also we have developed in-house custom reconciler to maintain the cluster state to the desired level. Next, yeah. So now let's discuss when we had this why we transitioned to use Strimzi for our Kafka ecosystem at Maersk. Firstly, we are part of a platform in Maersk who works on building the technology backbone with the goal of offering a seamless developer experience. And that's our vision. So, as part of our strategy, we work towards adopting to an open source technologies that allow us to benefit from the economy of scale. So not just Kafka or the streaming services as a bigger unit in our organization, we also have a unified approach to using these open source technologies. Like we have a centralized observability platform, which is also based on open source technologies, and we have Kong gateways and service mesh products, etc. Many of these, like which falls into this, our business platform basically, right? So this means we can leverage a vast community, reduce the cost, and avoid vendor locks in when we use these SaaS products instead. So, secondly, Strimzi helped us to build internal capabilities and supports inner sourcing. So this enables us to tailor our Kafka solutions specifically to Maersk needs and enhancing so that we can enhance the flexibility and innovation at our organization. Moreover, we developed robust internal knowledge on managing and administering our Kafka ecosystem throughout these years where we had been working, a specific engineering team had been working on, especially managing this Kafka ecosystem. So this expertise ensures we maintain a control and can quickly address only the issues that arise. Any issues those arise when we actually move to Stringy based deployment, because we have this in-house capability or knowledge with respect to the Kafka administration. So finally, with rapidly increasing adoption of our Kafka platform during these years after we started offering Kafka as a platform, we reached a point of no return, and Strimzi came into as a savior to support our scaling needs effectively, ensuring we can keep up with the growing demand, so that we can host a self-managed Kafka system in-house, and we can make the cost-effective solutions for our organization. And can you move to the next slide, Steph? Okay, so I'll hand over here to my colleague Sai Charan to go over a little bit in deeper on uh, how we were able to set up this self-managed Kafka cluster, which is called Retina, which means like reliable event transfer in action. Sai, over to you to take us through.
Yep. Thank you so much, Ravi. Thanks, guys, for having me here. This is Sai Charan. So, till now, we have discussed about what's the past and what's the future. So, here is the diagram, or here is the flow that illustrates how we are going to or how we developed a self-managed Kafka ecosystem in Maersk. So you see here we have Strimzi clustered. So we figured out, okay, deploying the Kafka is easy, but the main question arises how to manage the system. So there involves a lot of upgrades, lot of maintenance activities, since it's a central nervous system for tenants. So any lifecycle management activity that is associated with the Kafka will have a huge impact on overall business across the organization. So that's where Strimzi helps us in maintaining this deployment process and management of the clusters, lifecycle management at ease for us. So that's where huge thanks to Strimzi on this particular use case. Let's deep into the architecture here. See, on the right side, you see there are the Strimzi cluster, which is running in the region. So what we have done basically is that we have deployed the Kafka on Kubernetes using the Strimzi operator. Along with just not just deployment, we wanted to ensure we have a reliable, scalable, and highly secured system. So by default, Strimzi provided some of the features inbuilt with respect to the security, and with respect to the highly available system. What we have done is deployed the Strimzi based Kafka clusters in multiple regions, and then have the data replicated between the clusters, so one can act as a disaster recovery or an active-active solution. So here again, for the replication of events between the clusters, we use Strimzi Mirror Maker 2, which comes out of the box from the Strimzi. So we don't need to have much hassle experience to deploy all those. Now, as Ravi was talking about rapid increase of adoption, and then there is no point of it in going back. The main thing that we need to look at as an organization is to align with the strategy and then provide the seamless developer experience to the business stakeholders who are going to use the Kafka platform. And along with that, as I mentioned, there will be a lot of changes, configuration things that goes in while we are managing this particular Kafka cluster. So how do we deploy? How do we automate a lot of process? So how do we reduce the toil in doing the same repetitive work again and again? So that is where I would like to just quickly focus on the self-service part. See, on the left-hand side, you can see the self-service. So here, what we have done is that we used GitHub and along with the GoLang APIs, which provides as a self-service layer for the business stakeholders to deploy the Kafka objects that are required for them at ease. So what basically it performs is that it takes the input into the Git via the PR process. For example, the topic name, the partitions, whatever it is, it takes. And then once the user checks or raises a PR, we'll be performing a set of validations to make sure all these inputs provided by the user in the proper stage and then can be accommodated with the Kafka clusters. And then our API takes this input, validates, and then converts this inputs of the tenants into a meaningful YAML definition. And from that, it will be pushed into the Git repository where we have integrated our Flux with customization into the Kubernetes clusters. So by doing so, the turnaround time of deploying any Kafka objects was pretty easy. And then we do not need to spend a lot of hours in then doing the repetitive process. So that's where the self-service actually helps us. And coming to the security part of it, when we build a such large scale platform, we need to be really secured on how we are going to transfer the user credentials, the certificates, everything to the respective business stakeholders. So that's where we use HashiCorp Vault as our secret management solution. So whenever the self-service kicks in, it creates the required credentials and the certificates for the users that are required to connect to the Strimzi clusters, and then pushes to the vault where the users have a respective access to their secrets engine in the HashiCorp vault. From there, they can fetch it. So as a whole, as a platform engineer, without any intervention, that one tenant can easily onboard and then use the particular, just focus on the development and then have the Kafka used at ease. So that's with respect to the self-service. And coming to the monitoring and the connectors part. So right now, as we mentioned at the Maersk, we are transitioning into the open source technologies where we have centralized observability platform. We have integrated the Strimzi clusters running into the particular centralized stack using Grafana and Prometheus, and we export all the metrics using the Strimzi Kafka exporters, where we'll be able to analyze and view the metrics or build the alerting based on this particular rules. So, and along with that, since Strimzi is an open source where we can have a lot of open source connectors that can be deployed. So along with normal just native publishers and consumers, we have the option to deploy the open source connectors which are available, and or develop whatever we have to have a good seamless integration with the external systems like MQ, database, Postgres, etc. So quickly that covers my architecture, and by combining all this, we have a package with Retina, and using this package, we are able to deploy seamlessly the combined as the Kafka as a platform in multiple Kubernetes clusters using different cluster topologies. So here, when I come to the features, we can see shared, dedicated, hub and spoke. So since it's very easy for us to deploy something, we have segregated into multiple categories. Shared, where it says we have segregated events type on the business, where the events can be consumed across the multiple platforms across the Maersk. And along with that, dedicated events where independent Kafka clusters will be provisioned for the platform teams, where it will be used for their internal events. And along with that, hub and spoke model, where we aggregate the data between multiple clusters and then store it into one particular cluster for any kind of event streaming needs. So overall, we have built a very robust system which is highly available and reliable with 99.99 SLO to the tenants, by having a mirror maker with replicated the data across. Along with this, we have the schema registry deployed as well for the data quality as well. So we support Avro, JSON, and Protobuf. So with that, I would like to hand over to Stephen to talk about the integrations and the toolings that we did on top of Strimzi to make the user experience more enriched. Over to you, Stephen.
Thank you, Sai. Thank you for your insights on the architecture. Before diving into the different tools that we have created to make the DevX experience even better on top of Strimzi, we would like to show some numbers. It's always funny to look at some numbers on the activities in the clusters. This is actually an integration map from Maersk showing all the different terminals that Maersk is operating. So why are we actually showing this map? It's because we are slowly rolling out what we call routine on edge. Routine on edge is, as Sai says, another flavor of our package that we can deploy in different terminals or on ships or on anything where we would like to run a local Kafka cluster. And currently we have Strimzi running in Barcelona, Gothenburg, Tangier, Mumbai, and I've probably missed a few things since missed a few terminals since they're rolling out every day. So we are not only running Strimzi in cloud, but we're actually also running it in the terminals to make an even better system for the company. If we look at the numbers, we can see that we are having right now we're having more than 210 tenants. A tenant is a team, so more than 210 different teams in Maersk using our Strimzi clusters in total, combined with the routine on edge. clusters. We have 63 clusters currently running Strimzi across our environments. And on those 63 clusters, we have more than 300 brokers in total. When we look at the topics, we currently have more than 13,000 topics, including almost 180,000 petitions across those topics. Most of these topics and most of the data are running on a shared cluster. As I also mentioned, the dedicated clusters doesn't have any restrictions on schemas. They are more loose in their topology of deployment. But on the shared cluster, we do enforce schemas. And currently we have more than 22,000 schemas, so we can at least see people are evolving their schemas, even though it causes some problems once in a while, and we'll cover that in just a few slides. When we look at the events on how much our platforms are used, we can see that we are receiving more than 250 million messages per day across our clusters, most of them going through the shared cluster. When we look at a more real-time scale, we can see that we on average receives 65 megabytes per second and sends 90 megabytes per second. So that's some of the few numbers. As this is a migration case study, do note that this is only numbers from our new platform, and we're still in the progress of migrating the last ones from our old platform. So these numbers are rapidly growing. These are from just a few weeks ago, so it might be even higher now. Okay, let's talk a bit about how we have enhanced the DevX experience on top of Strimzi. So one use case when I joined Maersk and joined the streaming services capability, one thing I often heard was from one of the complaints I often heard from the Confluent solution were this Confluent control center, also called C3. Tenants were not happy that they could not browse their messages. They would really like to see their messages in real time while they were debugging and developing their new topics. I mean, this is a feature available in C3, although you need to give full admin access to the whole C3. And since we have more than 210 teams using our platform, we don't want to give all of them admin access. That was too big of a security risk, cyber security thought. So we needed to do something ourselves. And what we have implemented is this Retina Manager, it's called. It's a read-only platform for tenants, for all tenants to access and view the topics, the messages on the topics, the brokers, the clusters, configurations, anything you can think of, even connectors as well. It's built purely on open source. You can see the link in the top right corner. To the open source project that we have forked and contributed to and developed on top of it, internal features. I'm not sure this is the right repo anymore, since they have been forking out to a new one. If I recall correctly, the new one is called Kafka, but they have a documentation in the old repo where they link to the new one. In average, we have more than 300 users per day accessing this Retina Manager, primarily engineers, and more than 7,500 requests querying the Retina Manager. One of the most wanted features is, of course, the message browsing. That was why we even built this platform. And in general, all messages are obfuscated on the platform, so only the ones your ACLs allows you to view and consume or publish to, those messages will be demasked for you. So there is a security by design in the whole implementation of the Retina Manager. Going back to the schema problems, we do see a lot of confusion about schema involvement, what's available, what's not available, how can we make this process even better. So recently, just 2 weeks ago, Maersk has open sourced this schema compatibility UI component that we have built internally. The link is in the top right corner. It's a standalone open source Apache 2.0 license tool. It's made for our tenants, our consumers, to fail fast and be able to quickly respond and evolve on schema changes rather than waiting for the pipelines to fail, because we also do validate schemas in our pipelines. but what if it could be an integrated part of their development experience instead? So we have launched this project where you on the left-hand side can paste in your current schema, and on the right-hand side you can paste in your new schema. And based on your compatibility level, we support all of the normal ones, backwards, forwards, full, and none. And based on your schema type, we support currently in the project Arrow, JSON, and Protobuf. It will give you a meaningful error message when you press the validate, or it will say validation successful. Here we can see that we're checking for backwards compatibility, but we have added H2 on the right-hand side, which is not in the previous schema. So this is obviously not a compatible change to the schema. Sai quickly mentioned, and Ravi as well, our observability platform we have in Maersk. This is what we use on our daily basis to keep our SLA and SLO as high as it is right now. We have a fully internal and open source based observability platform based on the Grafana stack. We have Prometheus, Grafana, front-end observability, Loki, Mimir, and Timo for all the different things like metrics, traces, logs. And we have built quite a lot of dashboards, and we have also reused some of the Strimzi dashboards in our daily ops call. So the dashboard you see in the back is our daily dashboard we use in our ops calls to check the health of all our clusters to see if there is something wrong in there. On top of that, not only observability, we have also built a full alerting system on top, utilizing the linear regression in Grafana to predict whether new alerts comes. Everything is alert by code, so it's synced back and forth between Prometheus and our GitHub repositories using GitHub Actions. And in Maersk we have an internal build system called Hedwig on top that will call you or message you if an alert of a certain criticality is being fired while you're in the on-call shift. So yeah, our whole infrastructure is not only based on Strimzi, but we also have a lot of other things added on top in terms of the enterprise and the reliability we need to provide in Maersk. Last part, yeah, it's basically just a thank you to the Strimzi community. We in Maersk thinks it's a good idea to contribute back to the projects that you are heavily involved in and heavily rely on in your infrastructure. So lately, the Retina team in Maersk has been contributing to Strimzi, and in the current version 0.4.1, we have 5 pull requests that are going through that are released as part of this release. One of them is what Paolo also mentioned during the keynote, is this new dashboard for metric observability. So basically, we have built a dashboard and exported metrics on certificate expiration, both for clients and for clusters. So you can set up alerts and basically in the new Strimzi 0.4.1, if you pull this one, you will also get this dashboard for your organization that will list all of the certificates in your Strimzi clusters and show expiration. And then you can build with your favorite alert tool. You'll be able to build alerts. On top of that, we have alerts to know when we need to refresh our certificates. That's one of the things. There is also a few other improvements for the Grafana dashboards, and yeah. So what does the future look like? Well, the future is of course still based on Strimzi. If you recall the architecture from our old solution, it's all right if you didn't. There were this whole section of on-prem, and we have not discussed that yet in our new Strimzi-based solution. So this is of course something that we are looking into, because we want to do a full decom of the old system, but that requires us to support the on-prem applications that are running in legacy software like mainframes and stuff like that. So I will hand it over to Ravi for a quick walkthrough of our future on-prem solution of Retina.
Sure. Thanks, Stefan, again. So currently, whatever we have discussed until now is specific to the cloud environment that we have in Maersk, right? And because we have this also, good amount of Kafka existing in our on-premises DC on VMware. So right now, what we are doing is that we are connecting into the cloud Retina, I mean the cloud Strimzi based solution, using the Mirror Maker 2 here, along with we have also in our cloud solution the schema registry, which is a community licensed version of Confluent. So because we don't have in Mirror Maker any schema translation available, we use open source single message transformer code to do this schema translation by customizing it to our needs. So this is used currently also in our migration to the Strimzi based Retina Kafka ecosystem, as well as replicating the data from our data centers into cloud. So going forward, as we are also modernizing our DC infrastructure to be a cloud-like infrastructure, having Kubernetes in there, we are gonna deploy our solution, the Retina solution, which is based on Strimzi, into on-premise, and then migrate the existing VMs infrastructure into these Kubernetes using again Mirror Maker 2 as our tool for migration. And this is work started but going to come in future soon, where we use again Strimzi based solution to run in our on-premise cloud infrastructure, and then use the same components to integrate with for security management, which is a HashiCorp vault, and then the centralized observability platform, etc. So while we are replicating that into the cloud the Azure cloud Retina, we will be using GTM to actually send the messages or the events to a particular cluster, and then fail it over onto the other cluster as a disaster recovery solution. So that's something which is going to come soon in our future on the on-premise side. Thanks, Stefan. You can move on to the next slide.
Thank you, Ravi, on those insights. And our last slide, which is as another future component, we are currently kickstarting that right now, is of course stream processing. This is the new hot topic in event streaming, and we also see a lot of need for stream processing across Maersk. We have a lot of things running in Spark already, and we wanna bring the stream processing capability closer to Kafka. So what we're looking into is, like on Strimzi on Retina, is an automated self-service for stream processing. So basically co-running an Apache Flink cluster next to the Strimzi cluster. It will be an API first architecture, like for our Strimzi clusters, based on GoLang and also GitHub Actions for the self-service. We will initially discover some predefined templated jobs. So we'll do the jobs that will be templated away in self-service to make sure that all of the jobs are running on in the same style. For better utilization of the clusters. Later, we will also open up for custom defined jobs. But this is the latest thing that we are working on to extend our Strimzi journey in Maersk. And that was it from our side. Any questions from the audience, Paulo?
I see there are a lot of questions. Maybe do we have some time to answer them?
Yeah, thank you. Yeah, first of all, thank you very much for your session. It was great. It was great to see how Maersk is using Strimzi today. We have 5 minutes, a lot of questions, so I will go through a few of them, and then you can stick around in order to answer the rest. Or yeah, if the next session we start, we can just move on the Strimzi Slack channel. I will create a dedicated thread for you. So the first question is, did you consider other operators before setting on Strimzi?
Yeah, go on, Ravi.
Yeah, so yes, maybe probably 2 years back when we actually started this journey, we also verified or validated other operators. I'm afraid if I can take the names of them. But what made us to move Strimzi is basically for a couple of reasons. Either those were licensed operators, or which are open source were not as feature rich as Strimzi is. So when we actually ran Strimzi, we couldn't really find any difference of how we are actually using our existing infrastructure with respect to the seamless developer experience. First point. The second thing is that the community support that Strimzi has, I don't see, like, for other operators which are in the market, at least which we have gone through and then validated. Even today, I mean, we go through a lot of issues or problems when we try to improvise our solution self-service using Strimzi, and the answers we get on community are very fast and also accurate. So that's another reason. So apart from the, if you want to go to licensing products, of course they might be more mature, but that's what we wanted to avoid. And also there was one another operator also which we have validated, which was not as Kubernetes friendly as it was for DCs. So these are the reasons why, like, we have chosen Strimzi, and we are happy for the decision even after 2 years.
Thank you. That's great to hear. Yeah. So the next question, maybe it was
I can
already
read out the
answered.
next question, Ravi. Did you develop your own format for defining resources in the self-service and then transform that into Strimzi resource format? Or are you using Strimzi format in your self-service directly?
Yeah. So I can take that up quickly, Sai, if you want to add, you can.
Sure.
Later. So our self-service is not, so Strimzi is part of our self-service. So we have actually developed a package which is a combination of GitHub and APIs that are written in GoLang. So we give very simple format today as an input request to the user. Like, user will request us in very simple format, kind of, this is your region where we want this resource. And then our GoLang APIs actually read that and then converts it into the Strimzi understandable format, which is nothing but the CRDs. After which our orchestration pipeline gets triggered, and then the whole setup comes to them. And a future aspect of this is that we are actually working on making this available through a UI, so that the user need not have to go and request in GitHub, send a request for a request a file in GitHub with whatever the details that resource that he needs, but he can actually go to a UI and then in fact request for what the resource he needs, and then automatically it will be provisioned for him.
Yep.
So let's go with the last question.
Thank you.
Just 1 minute.
Palo, you're
Hear
back.
me? Can you hear me?
Yes, we can hear you, Paul.
Yeah, just last one question, and then we have to wrap up. I will go with this one. Do you think your Strimzi setup saves you money compared to the Confluent stack before?
I mean, it's at least from our perspective, it's not only a money perspective, because you cannot put money on resources and internal knowledge. First of all, we have had quite a few incidents on Confluent where we were struggling getting things to work. I mean, we have also met quite a lot of good support. So by having the knowledge internally in the company, we can quickly react if something happens. Secondly, as Sai also mentioned, we have a much bigger deployment topology of our clusters, so we can support a lot of different use cases. In the old system based on Confluent, we only had 2 clusters in production, whereas now we are having 35 clusters in production, and also having the ability to run Retina on edge. So I mean, to me, this is not only a comparison of cost, but it's also a comparison on flexibility and the ability to react yourself fast if and when something is happening.
Yeah, thank you, Steffen. So we are running out of time. I
Right.
will
I think there
say,
was another question. Do we have schema resistant Kafka connect? Yes, we do.
I don't think we have any more time for questions.
yeah, sorry,
All
Sai.
right.
Yeah. So
No,
let's
but we'll
wrap
try
up.
to answer them in the chat, Stefan, later.
Yes,
Yes, let's wrap up here, and you can stick around and answer into the chat. So
sure.
thank you very much for your great session, folks. And yeah, I hope that you will continue to attend the rest of the sessions today, right?
We'll be around.
Yeah, thank you. So
Thanks.
for the
Thanks,
attendees,
everyone.
see you later in 10 minutes. We are going to have a coffee break, and with the next session will be at 4:40 European time. See you then.
Thank you. Bye.
Thank you.